Hello friends, Jermaine here and welcome to this mini course. We're going to be building a contacts list application with Flutter, running a Dart backend and storing our entries in a MongoDB collection. This is going to be an update to the 2020 edition, so most of what we'll implement will look familiar if you've seen that one already. However, there'll be some notable improvements, such as we'll be using the shelf library to build out our Dart backend, and our solution will be null safety compliant, which will feature a WebSockets implementation. This is the demo featuring what the Contacts app will look like. So no contacts are listed. We can go ahead and add our first contact, which shows up here. We can refresh on the iPhone, which shows that contact here. We can add a lot more contacts, which once it goes past the viewport, we can scroll to see the extra one here. And hitting refresh on the web shows what we've added. Also, making deletes would show the changes. And when there are no contacts, we are back to the screen. And looking at our WebSockets implementation, we see that we don't need a refresh button in this case, because adding an entry will automatically broadcast that update to the other connections on our WebSocket server. And before we get started, if this is your first time to the channel, be sure to hit the subscribe button for future tutorials demonstrating how to build full stack applications with Dart and Flutter. And without further ado, let's get into it. Over here, I've got a setup for the Contacts app. This app contains two packages. Contacts app client contains the logic for our Flutter app, and ContactsApp.io contains the logic for our backend server. This package setup is also available on GitHub, so you can go and download it. We're going to start with ContactsApp.io, so this is the server side. We have the following dependencies: MongoDart, which is a client for communicating with our MongoDB database, a couple of shelf packages, and this package which works in combination with Shelf WebSocket for creating our WebSocket server. We've got a Docker Compose file, which is responsible for launching a MongoDB database that we can access using the following credentials. And in fact, I'm going to run this right now by doing Docker Compose app-d. And now we have MongoDB running. Let's come to our main.dart file, and we need to handle these 4 comments in order to get our server running. Firstly, we need to connect to our MongoDB database. I'll do db.create and we'll import the MongoDart package. In here will be our connection string, and we make sure that our connection string contains the login credentials. Next, we'll open a connection to our database, and then we'll create an object which we'll use to access our contacts collection. And then I'll just print out this message just so that we know that we were successful. Let's create our server. I'll start by defining a port, and then we'll create a router object. And let's import shelf router. Using this router object, we'll create a basic route. This route handles a GET request to the root, which just returns a hello world response. Next, we need to listen for incoming connections. We'll define a pipeline object, and we'll add the request logging middleware, which comes from the shelf package. This will essentially log out the requests coming into our server. And then I'll add our router object as a handler function. And then we'll run our server with hot reloading enabled. We'll run the serve command, which will take our handler, and then the host would be this one, which should import the Dart.io library, and then we'll pass our port in here. And also with serve, we need to import the shelf.io library. And then I'm going to run this file by pressing F5. Our database is open and hot reload is enabled. So let's make a call to our server, and then we get hello world. So that looks good. However, we are not going to be defining our routes over here. Instead, we are going to create a separate router object, which will encapsulate the logic for our contacts REST endpoint, and then we will mount it as part of this one. In our lib folder, I'll create a new file. I'll call that ContactsRestApi. We'll import the following packages. We'll create our class and define our constructor function. This will require an object pointing to our collection called store. We'll have a getter on our class called router. In here, we'll create our router object and we'll return it. However, before we do, we'll define our get route. And in our get route, we'll query our collection for our contacts. And then we'll return an OK response with our encoded contacts information. And we also set the correct content type, which is application/JSON. In order to use our REST API, let's come back to our main.dart file, get rid of this get method call, and instead we'll do app.mount. We need to define a prefix, so we'll call it /contacts, like so. And then over here, we'll use our Contacts REST API. So let's export it so that we can access it via this import. So I'll come to ContactsApp.io and then we'll export our Contacts REST API. So we should be able to instantiate it here, and we'll pass our collection, and then we'll do .router. And because we created a new file, we'll have to restart our server. And let's make a request. We make our call, and then we get our response, which is empty at the minute, which means that we need to create our endpoint that will allow us to add contacts to our collection. We'll define a post route. We'll retrieve the JSON string that we'll be sending to the route, and then we'll decode it into a map object. We'll insert this into our collection, and then we'll retrieve what was inserted into the collection, which contains the auto-generated object ID. And we do this because we return a 201 created response containing the entry that we added. So I'll save that, and then let's test it out. We have our payload over here. Let me hit send. And we have route not found. Okay, looks like I'll have to restart the server. Let's try that again. Okay, there we go. So the entry was added to our collection. We retrieved it, which came with this auto-generated ID. Let's add another name to our collection. Okay, and we got that. And if we do a GET request to our contacts route, we should receive the entries that we've added. Now let's implement our delete route. We'll do app.delete, which takes in a path variable called ID. And in this case, we've added a regular expression after the pipe character. We're just saying we want at least one character or more. You can make the regex a bit better, but this should suffice for now. Also, this ID represents the object ID that was returned to the client when we make our GET call, and also when we receive the response when we make our post request. This path variable is accessible via this variable here. Using this path variable, we'll invoke the delete one method, and over here we'll have an equality match on the underscore ID field. The value would be object ID from hex string, which will be our ID. At this point, we'll return an OK response with the ID that was removed. So I'll save that and I'll restart the server. We'll go to Postman. Let's delete this latest entry. And our delete endpoint, and then our path variable would be this one. And let's send. And I got the wrong route. Should be contacts/ID. Let's try that again. So we got a success response with our entry that was deleted. So if I come back here to our get route, the other item is gone. So this concludes what we need to do for our Contacts REST API. Next, we're gonna implement our WebSocket based API for handling WebSocket connections. On the lib folder, I'll create a new file. We'll call this ContactsSocketApi. Let's import the relevant packages. We'll create our class and our constructor function, which contains a reference to our collection. I'll create a getter for the router field. And in here, we want to return a WebSocket handler. And in here, we define a closure, which gives us a reference to the socket that is currently connected to our WebSocket server. We'll listen for messages on the socket's stream. And for now, we'll decode and print the message that was sent. Let me save that and I'll export that over here. In our main.dart, let's mount another route, and then we will instantiate our socket API and return its router. Let me restart the server, open up Postman, and let's connect to our WebSocket endpoint. We'll send the following message. Let me disable that, but should be okay. Okay, so we got a message over here. So it's actually gone through. And effectively what we're going to be doing is we'll be sending JSON messages across, which will have an action and then a payload associated with it. Let's return to our Socket API. And then in here, we'll look at the action key. And if it's equal to load, we'll retrieve our contacts and return the encoded contacts list by invoking the add method on socket.sync. So let's save that, restart, I'll connect again, and let's send. Okay, awesome. So sending that now gives us this response. Let's configure two more actions. One will be for add and the other will be for delete. For the add operation, we'll insert the following map object into our database, and the actual string will be sent via the payload key. I'll disconnect, I'll connect again, we'll make this add, and then our payload will be the name we want to add. Okay, let's go. We got a message sent. We actually didn't send a response back, but we can see in our debug console that it was received. And also if I change that to load, it should have given us both entries. Yeah, it looks like the hot reload isn't working, but no worries. Let's restart. And I'll connect again. Let's add this new entry. Okay, let's load. Okay, good. So now we got the entry over here. And then for delete, we'll delete our entry from our database, matching the object ID that'll be passed in via the payload. So I'll save that, reload, retrieve our data, and let's delete this entry by making an action delete. I'll paste that in there, and then let's send that across. Okay, so now let's do a load. Okay, good. The second entry is removed. In fact, since we want this to be done in a real-time fashion, we can move this logic all the way here after these two operations, which means that whichever action we send across will always be sent back the updated contacts list. So we can get rid of this load part and save that. Let's restart the server. We'll reconnect. Let's add a new name, which gives us the full entry. Let's add another name, which gives us the updated listing here. Okay, let's delete this last entry. Okay, so now we got two entries. That's good. And if we just do a load, that should return us the same collection back. And this pretty much is what we need to do on the server side. We have both our REST API and our Socket API working. One more thing, each WebSocket connection creates a different WebSocket object. We need to store a list of all our connections on our WebSocket server and then send the updated contacts list to those sockets, because each socket represents a separate connection. So we'll do that here. We'll create a sockets list, and then over here we'll have a for loop which just says for each WebSocket connection in our sockets list, we will send the updated JSON list like so. And after our listener method, we will add each socket connection coming in to our sockets list. And let's refresh. And this puts us in a good position to work on the client app. Over here in our Contacts app client, we're using the following packages: Dio for making HTTP calls to our backend, Equatable for equality matching, Faker for generating random names, and WebSocket channel for connecting to our WebSocket server. Over here in our main.dart, we've got the default My App Stateless widget. However, we are rendering a stateful widget, and the stateful widget renders a scaffold with an app bar. The body right now is a container, but we're going to change that shortly. And our floating action button is a row containing our refresh button and our add new contact buttons, which is these two over here. And in order to communicate with our REST API backend, let's create a service that can do that for us. So under our source directory, I'll create a new file. We'll call that api.dart. Before we create the actual API, let's have a model that will represent each collection item in our response. So what this means is that when the response comes in, we'll take each of our collection items and we'll convert it into a Dart object, which essentially is a data class. This data class will be called contact. This will have a private named constructor, which will accept the following fields. And then we'll have a factory constructor, which takes in each item response. And for each item, we'll retrieve the name and then we'll produce the initials based on the first letter of the first name and last name so that we can pass it in here when we instantiate our contact model. And then we'll extend equatable, and then we need to implement our override here. So this will be a list of strings and our props will contain these fields. Now that we got our contact model, we can go ahead and create our service. Call this one ContactSRestApi. We'll create our deal object, making sure we import the deal package here. And in fact, I'll import the following packages. Our deal object takes in the following base options, which will be our base URL. And then we'll configure our base headers, which will be JSON. Next, we'll have a method to retrieve our contacts. We'll make our get call. And then for our response, we'll retrieve the contacts items, and then we will convert each collection item into a contact data class object, and then we'll return the full list at the end. We'll have our second method to add a contact, passing the name that we wish to add to our collection. We'll make our call. This will be a post request containing the following map object, which will be converted to a JSON string. And then with the response that comes back, we'll convert that into a contact model and return that. Next will be our delete method, which will take in our ID, which we just passed that as our path variable. So let's save that. Create a new file under lib, call it ContactsAppClient, and then I'll export our api.dart file as well as our ContactsRestScreen. We'll come back to our ContactsRestScreen, and over here we'll modify our constructor function to require the API, like so. And then make sure that we got the right import at the top. We'll come back to our main.dart and we'll define our API here. Get rid of this const and then amend this import. Okay, that is good. Let's come back to our ContactsRestScreen, and now we can make our API call. In our state class, I'll create two fields in here. One will hold our list of contacts, and this field will be used to determine whether we display the circular progress indicator while we're loading our contacts or not. We'll have our override for the init state function. In here, we'll make our call to load our contacts, and let's define this method. We'll load our contacts and then we'll update our state, and we'll rebuild our state with the new contacts list and our loading boolean set to false. Okay, and it looks like we've hit an exception. So let's check the console. Okay, so this error related to cross-origin resource sharing. So we need to modify our server to allow requests from anywhere. So let us go back to our server. Under lib, I'll create a helpers.dart file. We'll import the shelf package, and then essentially we'll create a custom middleware which will send the correct header information to the browser. Enabling calls support involves setting these headers, at least this one especially. And for now, we've just set it to the asterisk, meaning that any client can access our server. We'll invoke the create middleware function, which accepts a request handler and a response handler. When the browser makes an options request, then we return an OK response with our calls headers, or else we just return null, which will move the request on to the next middleware function. And then in our response handler, we need to update our headers to include these ones as well. So I'll save that. Let's export it. And then our main.dart will add another middleware handler, which will handle our calls request made by the browser. Let me save. Let's restart the server and let's return to our client. Let me stop and start this up again. And let's check the console. I refresh the page, we've got our response coming back. Okay, that's good. We need to create a widget that will display our contacts list after we've retrieved it from the backend. So under source directory, I'll create a new file, call it ContactsListing. We'll create a stateless widget called ContactsListing, add the following import. Our ContactsListing will accept the following fields. These fields are our list of contacts and what happens when we attempt to delete a contact, and these fields are required. And this contacts listing will display a list view. And then for our children, we'll map over our data object, and then we'll return a list. And then in this mapping function, we take our contact object, we'll build a padding widget. The child will be a list tile. We'll also give this padding a key, which will be based on the contact ID. So we know that's unique. And for now, let's display the title from our list tile. This will be a text widget, taking the name of the contact, and we'll add some styling, setting the font size to 20. Okay, so let's use this. We can export our contacts listing widget, which means we'll come back to our ContactsRestScreen, and then in our body, we will have our contacts listing widget. Data would be our contacts object, and then on delete, we'll have this empty for now. Alright, so now we have got our list of contacts displayed here from the backend. Let's come back to our contacts listing widget and let's add our trailing widget. This trailing widget will be a material button, and once we press that button, we'll invoke the onDelete callback function, and then we'll pass in the contact ID like so, and then the child of this material button will be our delete icon. So let's save that, and that gives us this over here. We also need to display our initials. So this will be our leading widget. This is a circle avatar where the child is our initials from our contact model. And that looks like that. Let's return to our ContactsRestScreen and let's make use of the isLoading field. What we want is while we are loading our contacts, we will display the spinning indicator, or else we display our contacts listing widget. So that should look like that. So we should see a spinning indicator before we see that, which it shows, but it's a bit too quick. So I'll add a quick delay over here of 700 milliseconds just so you can see it. Yeah, there you go. And I'll get rid of that. Next, we'll look at our onDelete behavior. So if I copy that, and we'll invoke the delete contact method, which I'll define over here. This will invoke the delete contact on our REST API service. And then we need to do a state update where we remove the contact that was removed from the database. So let's try this. If I hit delete, that should disappear. And then we delete this, that should also disappear. Before we implement the method for adding a new contact, let's display a message when no contacts are available with a button to add our first contact. And we'll do that over here in ContactsListing. We'll create a new widget called NoContacts. This will render a center widget with a column. This will consist of the person outline icon, this piece of text that says no contacts listed with some spacing, and then the following material button that will trigger the operation to add our first contact. And in order to use this widget, we'll come over here and we'll have a check. If data is empty, then we'll display this widget, or else we display our list view. So let's check that out. Okay, clicking add your first will trigger the operation to add our first contact. We need a callback function to be triggered when this material button is clicked. So I'll define that here, like so, and then we'll use that here. We will have onAdd, which will invoke the onAdd void callback. We'll define that here. And then in our ContactsRestScreen, we'll have our onAdd callback, which will invoke the add contact method. We'll define this method right now. And then adding a new contact, we will create a faker object and be sure to import the faker library. We'll grab the person details from the faker object, and then we'll create our full name from the person details by grabbing the first name and the last name. Finally, we can make a call to our REST API with the contact, and then we can rebuild our widget tree, passing in the new contact that we just added. So I'll save that. And let's see what that gives us. Okay, there we go. We can also trigger this method when we click on the add new contact floating action button. So over here, like so. And let's delete those, which gives us that. We can also click that to add a contact and should work as expected. And let's see what this looks like into browser tabs. And then we'll visit the same URL. So both of those look like that. So we can add a new contact here like so. And then we can refresh, which nothing happens because we need to load our contacts. So let's try that. And then when I hit refresh here, we get the updated contact list. When we delete that and we refresh here, we get the updated contact list. And then add in new contacts here, displays here, and then once I hit refresh, we get the updates over here. Given that apps are real time nowadays, it is a bit redundant having this refresh button over here. So let's look at how we can get these updates working in a real-time manner with WebSockets. I'll close this, and on the source I'll create a new file, call it ContactsSocketScreen. I'll update the list of imports. I'll create a stateful widget called ContactsSocketScreen. Our state class will contain the following fields. One is a socket stream, which will stream our list of contacts every time it gets updated, and we'll use this field as a flag during the initial loading of our items. We'll include the following methods, which will initialize our state and load, add, and delete. In our build function, we'll render a scaffold with an app bar and the floating action button, which handles adding a contact. The body will be a stream builder, which essentially takes in our stream of contacts and will rebuild our contacts listing widget whenever we receive an update. Our initial data will be an empty list, and we need to pass in the stream, and then we'll define a builder function. In this builder function, we'll return our contacts listing. The data we will retrieve from our snapshot, and then for onAdd and onDelete, we'll invoke the methods, and we need to define the ID parameter. Right, so let's save this and let's export it. And then we'll replace our ContactsRestScreen with our ContactsSocketScreen. Clicking these buttons will do nothing at the moment. So now we can implement the API for communicating with our WebSocket server. Let's come back to api.dart, and then under ContactsRestApi, I'll create a class called ContactSocketApi. In our class, we'll have our API field, which will connect to our WebSocket server once it's initialized, and the URL will do a URI pass, which is localhost 8081 contacts-ws. Also, let's return a handle to the stream. We'll have a getter called stream, which will be listening for data from the backend. Since we are working with our contact model, we can map over the stream and convert it into a list of contacts. So what is happening here is that when our WebSocket server sends data to the client, we retrieve the data string, which is a JSON string. We decode it, which will give us a list of map objects. and then we are converting each map into a contact model. I'll import that in here. We'll make API required like that, and then we'll come back to our main file and instantiate our socket API. So now that we have access to our API, we need to listen for data from our stream. When the data comes in, we'll add our contacts list to our socket stream. And to retrieve the latest contacts on load, we need to send an event to the backend. So I'll come back to the API. Over here, I'll define another method. This will be a getter called send, which will point to the API's sync add method. So this add method takes in data, which is sent to the backend. We can come over here and then we will send a JSON string. So this will be our load action that we tested in Postman earlier on. So let me save that. We may be getting an exception. Let's see. Okay, we are getting a 404. Let's check our server. Contacts, my bad. Let's make it contacts. I'll restart the WebSocket server and let's restart this. Okay, so that gives us the response. Let's try that again. Okay, that's good. I'll come over here to our socket screen and let's make use of our loading field. We will have our check here on our isLoading field. So if that is true, we'll return the center widget with the progress indicator. And also, once we get our data, we'll set this loading to false. Let's implement our add and delete contact behavior. So when a contact is added, we'll perform the same set of operations, such as creating a faker object and then generating a full name. And then using the Widgets API, we will send across an encoded JSON object with the add action and our full name as the payload. So let's save this and let's try adding an entry. There we go. We can see it here. Let's launch another browser tab. And let me add an entry here, which displays over here. And if I click that, that shows up here as well. So that looks good. Let's handle the delete scenario. On delete, we'll use the Widgets API to send our delete command, where the payload will be our ID. And let's give that a go. If I hit delete here, that should remove it there. That's good. Okay, that looks good. And what happens when we delete all of it? It shows that. If we add our first contact, the changes persisted here as well. Lastly, let's check that this works across platforms as well. Let me launch this in an iOS simulator. I'll do a Flutter build web, which will build the Flutter project for the web. And while that's building, I'll start up the iOS simulator. The build process is completed, which outputs the built artifacts under build web. But here, so we can serve the web directory using the serve tool. And I want to serve the web directory in build, which means I can go to localhost 3000. And this is what localhost 3000 gives me. Let me run this app on the simulator. All right, seems to work as expected. So I can delete that. And then on the simulator in the web, we see the same screen. So let me add an entry. There we go. And I'll add a couple more here. I'll delete some of these here. I'll add a couple more here on the web. And I'll delete from the mobile. And as you can see, the real-time behavior works as expected. Okay, so in summary, we've managed to build an API backend for a RESTful endpoint and a WebSocket endpoint, which we use to manage a list of contacts in a MongoDB collection. Code for this is on GitHub. Check out the link in the description. And this brings us to the end of the mini course. If you enjoyed it, smash the like button and subscribe to the channel if you haven't already for future tutorials demonstrating how to build full stack applications with Dart and Flutter. Thanks for watching, and I'll see you in the next one.